Okay, our next presenter is Dr. Mozart Fonseca, who's based here at the University of Nevada, Reno. He's our beef cattle specialist and all-around wonder guy, I guess, for lack of a better term. So I'm going to turn it over to him, and he will be sharing his screen. And it was there, and then it left. So let's do it again. See if we can get it back in there.
Trying to find the correct file here. It's supposed to be there. Is it there?
Is that the correct one?
I think so. It should be the PowerPoint.
Use of dietary manipulation?
Yes.
Okay, great. I will turn it over to you and I'll be 1010 on the side here.
Should I leave my camera on?
You can.
Okay.
And remember, folks, if you have questions during the presentation, go ahead and use that Q&A function there at the bottom of the screen. So, Mozart, go ahead.
Thanks, Barry. Good morning, everyone. I'm going to talk a little bit about some of the research that we're doing in conjunction with multiple labs at the AVRS, our department. My take, I'm a ruminant nutritionist, and I work with some portion of quantitative mathematics related to beef cattle production system. So some of the things that we've been talking from past years are an increasing concern with the use of water by agriculture in general. I tried to get rid of, I can't see this slide. So, I brought it up to a couple of numbers in the past associated with how much water cattle actually uses throughout their cycle. So we have here to your right, I don't know if you can see my arrow, but anyhow, we have about 4,100 pounds of water being used, 41 gallons of water being used to produce about 2.2 pounds of meat. And we have here down the bottom to produce one during the life cycle of an animal. We use basically 215,000 gallons of water. So not only that, but we have some reports in the literature saying that if we were to keep producing animals, we should be looking into expand the ways that we are using and understanding the ways that we're supposed to be using the water that takes into that operation, which brings a higher pressure in the Western US, because during the calculations of water footprint, if you're irrigating that, the picture becomes even worse than that. So this is a pretty bad picture. So we've developed a couple of research projects to actually tackle that problem and properly measure how those animals or how much water they're drinking, if we could decrease the water, and if we manipulate their diet, given that they're always suffering from nutritional stressors in the field, what would happen to them, not only on the short term, but in the long term. So with those projects, we go from farm to fork. So we have an integration, my lab, Dr. Schutz's lab, and Dr. DeMello's lab. And some of the things that I'm going to talk today about are related to the cow-calf management and, of course, the footprint side of the things. And hopefully we can understand a little bit how they're actually important on the big picture of things. So we integrate. So even for the water, things that we're looking to are how the relationship with the grazing and plant composition, water within the plants, and how far animals would graze away from water sources as dictating their choices of feeds. We do know now that there's a pattern that they follow, and depending on their physiological state, the pattern will change. So we're looking into structural, morphological, chemical characteristics of the forage and how those forages will persist under grazing in arid conditions. And of course, to tackle that, we have to work with the nutritional quality and what those animals are actually eating. So one of the trials that we designed here at UNR was to answer the question, can we change how much water they are drinking? Because then we can explore to have them moving throughout the rangelands and actually improving grazing distribution. So we put some calves together, a very interesting system where we tackled supplementing the milk replacers that they were receiving by a carbohydrate supplementation and of course soluble carbohydrates and fat supplementation kind of deal. And the main results for these guys were that we were actually able to decrease the amount of free water that they were drinking. Free water is actually the water, it's the drinkable water, provided that they're also acquiring water from different mechanisms. The second to most important one would be the water that those guys were acquiring through the milk, which would put some pressure on the cow that is lactating with these guys. So what we saw is that by the supplementing, we were actually able to decrease the water intake by 15% of these guys. And the smaller the animal, the higher would be the impact of the mitigation, just because how the nutrient requirements work in a metabolic body weight basis. Other things that we tackled was the footprint. Could we decrease the water footprint by those guys by supplementing those guys strategically? And again, this was just a macronutrient supplementation. The micronutrients, the minerals were kind of balanced out, and we believe that we can increase even further that mitigation. But anyhow, from the total water that they consumed, we found that we could decrease for about 14% total water that they drank by supplementing those guys. So the water that would come from the milk, which would give some sense of alleviation for the cow, we saw that we could decrease the water footprint by the water that's coming from the milk, especially from the fat supplementation. We could decrease by 10%. So why we keep talking about these? Because we've saw that there are some states that they do have taxation from the methane, for example. And when we want to facilitate, in case that happens, we properly measure to facilitate water use rights and to establish a fair price for the use of water in case that happened at some point in time. So we're kind of ahead of everyone here on that one. So by supplementing, okay, we could decrease, but will actually affect the animal performance with that. So with the carbohydrate, we actually did not change average daily gain, and we didn't see any differences in body weight, but we did see an increase in average daily gain based on that fat supplementation. So we actually could potentially increase performance if that was needed at all. So for the overall water use, what we saw is that the best mitigator was a soluble carbohydrate-based supplementation, where we could actually decrease up to 12% of the overall water footprint. And overall water is all mechanisms that account for water intake or water uptake, and that by not changing immune systems or hydration response for those guys. Then we had a second question that we wanted to answer, is that we do know that we have variation in nutrient availability and of course forage availability within the pastures, and then we wanted to answer if that nutrient deficit that happens could potentially affect cattle offspring. So we ran a trial with breeding bulls, and basically we simulated two scenarios. One scenario was with an extreme body weight loss followed by a body weight gain, which is called compensatory growth. And we measured the situation where we have poor nutrient availability and rich nutrient availability. And we've done very interesting analysis going from measuring the seaming and the transcriptomics of the liver. And today, we're going to talk about more on the semen side because it makes sense as we're discussing these panels. So we actually fed Birdley's wheat to these guys at the point of growth stage. We believe that it was in the milk growth stage by the composition, but what really matters in this case is the amount of nutrients that gets to those animals at the end of the day. So we've got really interesting data related to that water use picture here. So first we saw that some animals, they actually have different efficiencies in how they use water. And then we saw that an animal at maintenance, so they're not gaining weight or the retention of energy in the body doesn't change. Usually they will drink 60.4% less water if they were suffering or undergoing the compensatory growth. And as you compared to the baseline with following that statistical pattern for the identification of more efficient animals. So we can actually tell by the way that the body changes and the way that the body behaves or the way that intake behaves, what's going on as far as the physiology of growth of these guys. So, and then we were able to actually decrease that water intake by 60.4% equivalent to over 8.3 gallons a day. And we were actually able to decrease water intake by 11% in these guys as per metabolic active tissues, which means that if those animals are losing weight, they will use that water more efficiently. And if they're actually at that point, they will drink less water. So you can create systems that can tell you what's going on with those guys, even though it's too soon to tell, right? So other things that we notice is that per kilo of gain, animals under the compensatory growth, they consume about 34% more water. Those animals that are undergoing the feed restriction will, with a decreasing maintenance requirements, will use about 16.2% less water as they catabolize their own tissue. And mostly that tissue will be fat, and they will actually decrease body fat thickness. So other things that are related to that rationale, they are associated with breeding programs. So as the importance of breeding for feed efficiency in this case is that as we breed to decrease maintenance, we will actually breed to decrease water intake, which somewhat would be advantageous for us here. So as per the compensatory growth, we see an increase. We can actually see a decrease in water intake about 13.1% as compared to the baseline of feed restriction. What else? We saw that so those distances here to tell you what is actually influencing the variables of water intake. And what we saw is that the weather does not always control water intake. So in the field, it's not really if you have a very dry environment all the time, or if you have high relative humidity all the time, that will control. It's moreover on their physiological state, whether or not they're losing weight or gaining weight. As they increase their performance, then the weather makes more difference than actually their requirements. So the bottom line is, if we were to decrease that footprint or over the strategies for the fattening cattle to increase bed fat thickness, we would have to increase the water intake by 20.1% comparing to those animals that are actually losing weight or in a negative energy balance. And a changing in composition towards more lean tissue would actually increase their water intake by about 15%, equivalent to 11 liters of water, or close to 3 to 4 gallons a day, right? So we got a good picture of how water can tell us what's going on. And remember, those guys were suffering from nutrient restrictions, right? So the water is just pointing us as we analyze the behavior, how could we tell how the performance would happen provided that they were restricted from nutrients. So, and then because of that feed restriction, we usually run the breeding soundness exam, and what we saw is that by doing the treatment of losing that much of body weight and increasing over the compensatory growth, we actually didn't see any differences on the soundness exam. So we couldn't tell if anything happened just by the soundness exam. And as far as body weight, we were able to return to the same body weight. Of course, we saw differences in average daily gain because one was in a negative energy balance and the other one was extremely positive with high average daily gain characteristics of a compensatory growth. But we did see something happen in a molecular level here, which I'm going to talk about very briefly, which is an epigenetic mark called M6A here. So if you remember, for those of you that were last year here, we talked about those molecular markers that actually turn on and turn off genes, and not necessarily changing DNA, but they can change to whether or not that gene will be expressed or not. So by decreasing or that nutritional state where they lost a lot of weight, we actually increase the amount of that marker. So if we took into consideration what we saw from the breeding soundness exam, is that those variables that we would evaluate on those bulls, they were basically the same. We got to increase actually scrotal perimeter and ejaculated volume. We did see most likely an increase in fat content in the scrotum at the end of the compensatory growth, but motility, progressive motility, vigor, we did not change. So we couldn't detect those changes that we saw in the molecular level. And as per the other data on sperm concentration, we kind of returned to the same. For spermatozoon that were normal, we kind of returned to the same conditions. The ones that were abnormal, we kind of returned to the same condition prior to that negative energy balance or that extreme weight loss. And we actually decreased the primary defects that we would see on the spermatozoon, but we increased the secondary defects that we would see on the spermatozoon. So, and that's correlated with that M6A. So, so is that good or bad? So M6A is associated with inflammatory response. It is associated with several diseases to animals, which may include cancer and inflammation throughout the digestive tract. So that could be hidden through the process, and we couldn't tell just by the way that we evaluate our bulls, but that was something that could potentially happen, and that would be passed on to the next generation. And basically that's what we saw. So it seems there's an independency between that M6A and sperm defects, but for sure, as the animals suffer that nutrient restriction, we increase that concentration. To the good side, there's a possibility that we increase the likelihood of the offspring getting obese, and that by means of expediting or improving the lipid metabolism, which for finishing animals would be advantageous. That means they're more efficient in depositing fat. So the calves that we'll be selling could be better off over the feedlot period, but we still have to evaluate. So the bottom line of these short messages is that there are things that are going on that we cannot actually measure by the way that we do our management strategies, but for sure they can be changing the output that we're getting from our cattle from year to year. So, and that those changes, some of them are in the short term, some of them are in the long term. In the case of M6A, they maintained over the recovery, and we couldn't tell that happened. So with my concluding remarks here, when I use that, say that the dietary manipulation, we can actually decrease that water usage footprint that might be advantageous as we properly calculate and estimate those values that some be a little bit off. We can actually increase productive efficiency if we were to decide to use breeding programs. And of course, breeding for efficiencies will be a big deal for us. And overall, we expect that we're going to increase our sustainability in general. So another thing that I think we're focusing here is that all those nutritional environmental stressors, they might be changing, or at least bringing more variability with the cohort for an offspring that we're getting throughout the years. And we're committed to try to measure how those changes are happening and how we could quantify, so one could use those information whenever you're choosing your bulls or devising your breeding program. And on the other end, by measuring those the water intake behavior, we can from the math side and the modeling side that I do, we can actually devise strategies, and we could use in conjunction with other management strategies like Paul will present later on with the virtual fencing that could help us to potentially improve grazing distributions and management alternatives. With that, I think I'm done and I'm over my time already. So if you have any questions, I'll be glad to answer.